Let alpha and beta be real numbers with beta not equal to 0. Determine all functions f of r to r such that this equation, you can read it by yourself, holds for all real x and y. First of all, we need to understand what kind of function f is. What do? We fix y, then x is real number, and beta x, since beta is not equal to 0, is also real number. Therefore, changing x, right hand side of the equation, has all possible real values. Therefore, f, which is left side of the equation, is also the function with a range of all possible real values. And this is important. It's not a limited function. Then we go next, point 2. Let x be equal to 0. Then we just plug this value and we see alpha times f of 0 is merely a constant, plus f of y. Since f has a range of all real numbers, we can call it a new variable z, which also has all possible real numbers. And this equals f of y. So we rearrange this equality and we get f of z equals z minus c. Aha! We already know that f of z is a linear function. So let us plug it back to our equation to point 3. So we plug it and then we rearrange and we get alpha minus beta times x equals c times alpha plus 1. There are two options possible. First, consider alpha not equal to beta. Then x can be expressed like this. But look, on the right side of this equation, we have a constant and some product of constants, so it's a constant. But x should be any real number, so it doesn't work. Therefore, the only remaining option is when alpha equals beta. So we have equation alpha times x equals c times alpha plus 1. And left hand side of the equation is equal to 0, therefore right hand side should also be equal to 0. And this is possible when c equals 0, and so alpha can be a real number, which gives us this answer: f of x equals x if alpha equals beta. And the other option, that this bracket equals 0, so alpha equals -1, so c can be any real number, and this gives us the answer f of x equals x minus c, so we plug it basically here, if alpha equals beta equals -1, and this finishes the answer.